Hey guys, so today we're going to start day 3 of lesson 6.5. This is the last day we're going to be spending on this lesson, and it's going to be a very brief lesson, all right? So first thing you need to understand is what happens when we introduce double bonds and triple bonds or charges into our molecules. And the answer here is there's really no difference. So whether I have single bonds or double bonds, I am still going to follow the exact same rules. If I have one central atom and two surrounding and no lone pairs, I will always have linear. If I have three surrounding atoms or three atoms surrounding a central atom and no lone pairs, I will still have trigonal planar. There's no difference. So if I go over here, let's take a look at this model. Let's add a single bond. There we go. As you guys can see right here in the molecular geometry, this is linear. Let's add a double bond. Now this is AB2, and you guys remember AB2 is still a linear molecule. Even though I added a double bond, this made no difference to my molecular geometry. Now let's add a triple bond. Now I have AB3, so I have a double and a triple bond, and look at that, AB3 is trigonal planar. And as you can see here, whether we have single bonds or double bonds or triple bonds, so let's get rid of this and just put 3 double bonds. In the end, I still have an AB3 or trigonal planar geometry. Let's get rid of these two, and let's put 3 triple bonds, or a triple bond and 2 singles. I still have trigonal planar geometry, right? Now, let's see what happens when I add 2 double bonds and a triple bond and that. Now I have tetrahedral geometry. I have 4 components and they are all 109.5 degrees away from each other. So as you can see, triple bonds and double bonds and single bonds all behave the same way when it comes to molecular geometry, okay? And last thing, so don't get tripped up when you see double and triple bonds. It's the same situation. And then when it comes here to polyatomic ions, when you look at this right here, this charge, don't let that confuse you. It makes no difference. Here, I can see that I have one central atom surrounded by 3 other atoms and a lone pair on top. You know this lone pair is going to push all of these downwards, and they're all going to repel each other. And because I have 4 components, I'm going to have tetrahedral geometry. And if it helps you guys, you can just go back to this table and find the one that looks most like the one that you're looking for, which is right here. I have 1 in the middle, 3 atoms surrounding, and 1 lone pair. When I look at that, I know that I'm going to have trigonal planar geometry, right? All right, so let's just go back. And that's the basic idea. Don't let double bonds and triple bonds or charges confuse you. They're basically exactly the same. Now, there are more geometries than just linear, bent, trigonal planar, tetrahedral, trigonal pyramidal, and all of that. There's also trigonal bipyramidal and octahedral, but we are not going to get into any of that. If you guys are interested, you can go ahead and look it up on your own. All right, so now go ahead. Today you are not going to be doing a quiz. You're just going to go straight in and start doing the revision sheet for lesson 6.5. Okay, so go ahead